told you be autopilot on. All right, so the recorder is running, and here is the whiteboard. And we're going to talk about statistics, 12.1 through 12.4. I'm going to try to cover everything I can that I usually teach and keep, pretty much. Let me make sure I got this thing focused. I think I got it. Yeah, there we go. All right, so y'all should be able to see everything I write. All right, first of all, there's two words, statistics. There's the capital statistics. And then there's the lowercase statistics. We'll get to the lowercase in just a minute. Now, the capital statistics is basically the science of collecting, calculating, organizing, and interpreting. I don't know how to spell interpreting data. I think it's Preting, interpreting data. Okay. The science of collecting, calculating, organizing, and interpreting data. And that's the capital S. And I'm going to highlight that in pink because on a test, you will have to look to make sure if it's a capital letter or if it's a lowercase letter. Okay, capital statistic is science of collecting, calculating, organizing, and interpreting data. And that's going to be using words like population and sample. Population is always your big set. Sample is always your subset. Population would be how many Tri-County Tech students are over the age of 28. A sample would be how many students at the Anderson campus are over 20 or over 28. Now, the goal of statistics is to be able to predict the population by using the sample. Now, what does this do as far as save? Well, it saves time and what? Money. If you can take the sample and you can crunch it through the statistics that you learn in 2 or 3 probability of statistics courses that you take at a research university, okay? If you, do a survey and send it out to all the Anderson campus students, and you find out this information, and then you run it through all of the knowledge that you learned in those 2 or 3 research classes, and then you spit out a number for the population, that's the goal. That's what statistics and probability and all that, this science of mathematics does. It takes the sample and predicts for the population. Now, there's formulas that you use for the population. And those formulas use variables. But we don't call them variables in statistics, we call them parameters. And the parameters for populations are usually Greek letters, like mu and sigma. So I'm going to get my highlighter out here. This is a test question. Population starts with a P. Parameter. The formulas that we use in figuring things for the populations are made up of variables. Those variables are not called variables in statistics. They're called parameters. And they consist of Greek letters, and here's two right here, mu and sigma. Mu is the population mean. It looks like a funky lowercase m, cursive M, as in Mike. And the sigma, lowercase sigma, is a O, a lowercase O with a pompadour on top. Okay, so you got lowercase sigma, and then you've got lowercase mu, M-E-W. That is the standard deviation. Mean, population standard deviation. Well, what are the variables used in the sample? Does anybody know that? With the sample, you have formulas, and we use variables in formulas, but in statistics, we don't call them variables. Does anybody know what we call the variables for a sample? Anybody?
No, this is all new to me.
Okay. Lowercase statistic. And lowercase statistics are letters, just regular letters out of the alphabet, like X bar or S. So I'm going to take my highlighter out here and sample statistic. This is the population mean. This is the population standard deviation. This is the sample mean and the sample standard deviation. Now, why do you need to know that? Well, let's say you're sitting in a presentation 10 years from now at your work, and the person is speaking 90 miles an hour, and he throws up mu is equal to 28 and X bar is equal to 26. Then you know that one of them is a sample mean, the X bar is a sample mean, and the mu is the population mean. And you don't have to raise your hand and go, duh, what is that? You know, you don't sound ignorant. So that's why you need to know the difference between a Greek letter and a regular letter. You all know your regular letters from ABCs, okay? How many questions are on? There's two test questions on this page. One is what is uppercase, now actually three test questions. What is uppercase statistic? Population parameter go together, and sample standard deviation go together. I'm sorry, sample and lowercase statistic go together. So one question, two questions, and three questions. Now, in statistics, you have certain types of data. You have qualitative data. And you have quantitative data. Anybody want to take a stab at it? Qualitative data, remember this: blondes, brunettes, and what? Redheads. Blondes, brunettes, and redheads. What are they? Hair color,
Hair
right?
color.
Okay, these are what we call categories.
Okay.
The test, if I spell that right, the test that you take, whether it be a standardized test or whether it be a regular test, they will call it something that I never have been able to spell. Is it characteristics?
There, just a second.
I always want to spell it with an H.
I was always
but I
told
put
that it
the
was
H in the wrong
quality.
place. There it is.
Hmm.
Okay, so make sure you spell it right. I don't try because I always put the H in the wrong place. All right, I need to say characteristic, characteristic, and that way I can remember how to spell it. All right, so write that down.
Yeah, see, my high school kind of like I always was taught that it was like quality was like quantity and like not.
That's what I'm getting to, Mr. Pack. Unless you're going to steal my thunder, and take over my class, you're just going to steal my thunder,
I mean, I was just telling you what I was taught because I
No,
was like, categories
just
we didn't really.
forget it. Just forget it. Mr. Pack's going to teach the class now. I've been watching too much Bar Rescue.
All right, class dismissed. Thank you for attending.
Oh, wow.
All right. So quantitative data is the opposite, as Mr. Pack said. That's your numbers. That's your numbers with mathematical meaning. What do you mean, Hubert? Well, you got to have a mathematical meaning, because guess what? Guess what is a characteristic? Guess what qualitative data example is up here? Social Security number, area code. Social. Let's see. There's one more. What is it?
Phone number?
Oh, phone number. Those are all qualitative data, but they're numbers, but they have no mathematical meaning. In other words, can you take 10 Social Security numbers and give me an average? No. Because Social Security numbers, their numbers have no meaning. You don't add, subtract, multiply, or divide them. You don't do anything with those numbers. Those numbers are just like a name. Okay? So the standardized test will say Social Security number is an example of quantitative data, true or false, and you would say false, because these numbers don't have any meaning whatsoever.
Got it.
Give me two more examples. We got 1, 2, 3, 4. Give me two more examples.
Maybe your house number?
No, I'm not talking about numbers. I'm talking about, I got numbers here. Thanks. House number. That's good. But just give me two more examples, or address. House number / address.
Yeah.
Give me, okay, we got enough numbers. Give me non-numbers. Give me, something like blondes, brunettes, and redheads. What could you?
I don't know.
Black socks, white socks.
Okay, what, Mr. Pack?
I said red socks, blue socks, black socks.
Okay, what color socks? Okay, color.
Cat breeds?
Socks. What'd you say?
Maybe cat breeds?
Cat breeds. Good. I love cats. I don't
I know,
like
that's why I said
cats
that.
I don't like the cats that I know they're grown that way, but the cats that have no fur, I don't know.
Oh, the Sphinx cat?
Yeah, I can't handle that. Okay. Now I do
Dog
love my favorite breed of cat is Siamese cat. I love those cats.
Those are
I
pretty.
only had one my whole
That's what my
life.
mom has.
I love the Siamese cats. Okay, so that is a set of examples for qualitative data. Quality is a category. Quality. Quantitative data is numbers with math meaning, of course, height, weight, shoe size, age, and so on. If somebody in here is 26 years old, they are half of my age. Does that mean something? Yes. Half of my age, half of my number age means something by comparison to blondes, brunettes, and redheads. So that means that the number has mathematical meaning. You have a word now. So qualitative data, quantitative data. Make sure you know there's 2 more test questions right there. Now let's talk about numbers in statistics. Numbers in statistics. There's 2 types of numbers in statistics. Does anybody know the 2 types of numbers? I'm just trying to see how many of you have had probability in your, I'll tell you what, let's take a vote right now. How many of you, raise your virtual hand, has had probability and statistics in some form or another in the past? Take a second and we got 12 people. Let's see. How many of y'all? How many? Raise your virtual hands. Even if you sucked at it. Even if you didn't listen.
Nope. That's 4 people. Wow.
4 out of 12. So now I know what I'm dealing with here. Good. I always do that when I talk about probability. All right. So what's the 2? You can take your virtual hands down now and put it back in alphabetical order. Okay. Williamson, you got a question? I believe you. Okay. All right. So here we go. And I did, okay, speaking of which, I did see your questions in chapters 7 and 8 or 8 or 9, and we will go over those, or I'll do a video. I haven't figured out how I'm going to do that yet, but I will address those in this week somehow. All right. Here we go. The two sets of numbers are discrete and continuous. Discrete, there's 2 words I like to associate with discrete. Concrete and rational. Now, some of you may have studied rational numbers in high school. I'll give you several examples of rational numbers right here. 2 over 4, 7 over 2, 6, 3.33 with a bar over that, and 0.166 with a bar over that. Okay, now I've included fractions, decimals, and whole numbers, so you can't pick those numbers, or you can't say that's what they are. There's one thing that every one of these numbers have in common. Now I want you to sit and look at them and tell me what you think is in common. Take about 30, 45 seconds, and I want you to look at them. Yes, you could change this to 1/2 if you wanted to. I'll put or 1/2. I'm trying to take some of your answers away because those answers that you're thinking, oh, they're all decimals. No, that's not it. Oh, they're all fractions. No, that's not it. So I'm trying to do away with all those answers so you won't use those answers. Okay, now that's been about 30 seconds.
Can
anybody
is it
tell
because they
me?
represent real numbers?
Well, yeah, but I need you to go further than that. Tell me a little bit more. You're on the right track. There's two words I'm trying to think about. Two words that's in my head that these numbers all are. Can anybody think of and take Mr. Pack's definition a little bit further? The two words are predictable / locatable, if that even is a word. Why? Well, what is 2 over 4, or what is 1/2? That will always give you what, 0.5? Is there any other number that you could put right here besides 0.5? No. What about here? What's the decimal that you can make this one into? 3.5, Hubert. That's right, class.
I said that I was muted, my bad.
What's this next digit right here?
3 repeating.
So you can predict that. What's this next number?
Same thing, 6 repeating.
6. So you can predict everything about these numbers, can't you?
Yeah.
Okay, then what do you think? Let's see, I only have one number in irrational. What do you think is the definition for continuous?
You can't predict it.
Unpredictable.
And not easily like located.
Non-locatable, if that's a word. Non-locate. Let me give you an example. I want somebody take your well, we'll do it together. Pi, square root of 7, and the square root of 2. So let's go to our handy dandy calculator. And I don't want you to blurt it out because I want to show you what, you don't have to have a calculator. I want to show you what the answers are. So I'm going to hit clear here. Oops, no, I'm not. Second, quit, clear. There we go, clear. I don't know why I do that. Okay, so I'm going to hit pi, second, pi, and equals 3.141592.654. Okay, so what I want Miss Grindle to do, Miss Grindle, why don't you give me that next number without looking at a calculator and tell me what it is, just by looking at this pattern.
3.
How sure?
I was just guessing.
Yeah,
6, 5, 4, 3.
Why are you guessing? Why don't you just look at the pattern?
Because it's unpredictable.
Well, because
there's no pattern.
Yeah.
No pattern. No.
I just went off of that because it said 6, 5, 4 at the end.
Oh, yeah. That's cute. All right. So I can't do this. So I'm going to put, now the reason I said not looking at calculators, some of you may have a calculator that goes to 15 digits. I don't know. Okay. But if you look at them, there is no pattern. You can't tell what that next number is because there's no pattern. All right. Let's do the square root of 7. And I'll let you look and see it. 7 raised to the 0.5 power. And that's going to be 2.645751311. And somebody tell me what the pattern is. You can't. There is no pattern. and the square root of 2.5, 1.4, 1.42136562, and you can't tell what that next number is. Now I can make this a whole lot easier for you, even more. Okay, this is a girl question.
I'm already offended.
There you go. What is the difference between your scale at home and the scale at the doctor's office?
Nothing.
You know that ain't right. The
I feel
scale
like
at the doctor's office is broken. It always weighs you what?
I always wish you more.
It always weighs more than your house.
I don't have this
scale.
problem, so.
Okay. Now, why is that? Well, let me ask you another question. What if I told everybody to go in the AC parking lot and take, and I got a box of, I either got a yardsticks or measuring devices. I've got 5 different type measuring devices in a box. And I tell everybody to grab whatever measuring device they want to. And I want everybody to go out to the parking lot and measure the fire hydrant that's in the middle of the parking lot. There's 12 people in this class. Everybody with me?
Mm-hmm.
How many different measurements will I get, excluding the 4 people that can't read a ruler? We're going to go ahead and throw them 4 out. Okay? How many different answers am I going to get out of 8 people?
You shouldn't get any.
8.
I'm going to get 8 different answers.
No, you're going to get 8.
Why? Why am I going to get 8 different answers? Because, well, 4, we took out the 4 that can't read a ruler. We took them out. All right? Mr. Pack is going to go out there, and he's going to take his hands, and he's going to clean out all the mulch that is around the bottom, and he's going to measure from the bottom. Miss Grindle is going to go get a shovel, and she's going to measure, going down in the dirt, and measure where it actually hits the water pipe. Miss Hunter, she's mad because I told her to go out there and measure, so she's just going to say 3 foot. She ain't going to. Miss Bryant, she just goes, well, it's between 3 foot and 2 inches and 3 foot 3 inches, so I'm just going to say 3 foot 2 inches. Okay? Miss Williamson is going to be the other side, and she's going to say, well, it falls between 3 foot 2 inches and 3 foot 3 inches, so Miss Williams is going to say it's 3 foot 3 inches. Everybody get my point?
Yeah.
When you measure something, I want you to write down this word, and I'm going to put it in red. When you measure something, you're dealing with continuous. What is measured? Meters, liters, and grams. Somebody tell me what those represent. Meters, liters, grams. What do they represent?
You get what?
Meters, liters, grams. What do they represent?
Different measurements.
Well, that's real numbers. But like, when you like measure something, you get what?
Distance, volume, and what? Weight. Now, the reason I use meters, liters, and grams is because that makes you think distance or length, volume, or weight. And that makes you think those 3 things are measured. If I measure my weight at home and then I go to the doctor's office scale is going to put another 5 or 10 pounds on me. Or it's going to say 2 pounds over what I weighed at the house. It never works the other way around. Okay? Well, if continuous data is measured, What is discrete data? What's the opposite of measuring? Anybody want to take a stab at it? You do it every day.
Oh, counting.
Counting. Counting is discrete. Counting how many eggs are is in that bucket of eggs. If I asked each one of you to count how many eggs are in a bucket that I bring to class, how many of you will come up with the same answer? All of them. Unless y'all can't count.
Unless you can't count.
Unless there's like 15, if there's 15 eggs in the bucket. I'm not talking about 2 million. I'm talking about 15 eggs. And I bring those 15 eggs in a bucket, and they're Easter eggs. They're not crackable, so that you can't break one. Okay, they're plastic eggs.
You could totally break a plastic egg.
And I pass them around, and I tell you to write the answer on a piece of paper. All of you would get 15. That's
got it.
Now, there are several test questions on this page. So make sure you understand the difference between discrete data and continuous data. Data is going to be a lot of times your fractions, decimals, and percents, especially the ones that have no pattern. And then your discrete data is going to be things you count.
And repeating numbers?
Repeating numbers, yes.
Okay.
So you got at least 2 or 3 questions right here. What do you mean 2 or 3 questions? Well, they may say cars in a parking lot. Is that discrete or is that continuous?
That's discrete.
Discrete, because you count cars in a parking lot. All right, I'm going to give you one. All right, I'm going to give you one you're going to have to think, so don't blurt it out. Think about it for at least 5 seconds. Time. Be careful. All right, 1001, 1002, 1003, 1004, 1005. Remember, before you answer, remember, does everybody show up at the same time, or do other people come up at different times when you meet somewhere?
I'm going to say it's continuous.
It is. Time is continuous. There is an ongoing debate about time being discrete. A certain part of time is discrete. Like, how many hours are in a day?
Well, 24.
So one could argue that it is discrete as far as you're counting the hours during the day. Yes.
So then wouldn't the real answer be both?
It could be, but most people say time because time is measured.
I think that could be really confusing on a test because it depends on the context of the question in which they use the word time.
Go. Good job, Miss Grindle. Perfect. If I asked you how many hours in a day, you would say that is discrete. If I asked you how many people show up for a different, that would be continuous because people read their watch and people, have you ever seen 2 watches side by side give different times?
Yeah, that could be a minute off or whatever.
And then your interpretation of time, Miss Grindle, do you show up on time for events?
Usually, yes.
Okay, but when you show up on time, is there somebody that shows up late?
Always.
There you go. There's your answer. So as far as meeting and as far as interpreting time, interpreting the time can be continuous. So you got to be careful with that one. Okay. Now what? Well, there's a lot of reading in 1.2 or whatever. What is this section? 12. I think it's 12. I'm going to go ahead and tell you this right now. 12.1 And 12.2 is reading. And I've covered a little bit of that. What I'm going to cover right now is the bread and butter of chapter 12. Okay. And this is 12.3 and 12.4.
So what we just went over is 12.1.
I'm sorry, what? I think we just went over a little bit of both. Okay.
Okay.
A lot of that's reading. I want you to read 12.1 and 12.2. Send me homework questions, but a lot of it is basic definitions and terminology and stuff like that. You know, that's. I mean, we're talking about if I gave you 10 questions on the test, you might get 3 or 4 from here, and I've already shown you what the 3 or 4 I'm going to ask you. Okay. Now we're going to get into the math right here. This is the math. Okay, I've got to hurry because I only got like 8, 9 minutes. Now, most of you know how to do this.
Mr. Hubert?
Yes.
Before class ends, could you go over that thing I sent you? Because, like, I'm not sure if it's that symbol that you were talking about, but, like, I was, like, confused on that.
All right, I'll wait and look at it. I'll look at it. Okay.
All right, thank you.
Make sure you can find the following things, and most of you know how to find these. And I'm going to show you on the calculator. First thing you do when you get data is you got to put it in order. Okay? Put it in order. Put in order. And of course, we all know that means from lowest to highest, because lowest to highest is how we think. Nobody sits here and goes, well, let me start with 101 and let me go down to 0. Nobody does that. Okay? Lowest to highest. And you should be able at that time to find the mean, median, mode, range, mid-range, variance, and standard deviation. Now that we're going to spend this week going over all these things. Now you can go on the calculator and do it real quick. Okay, I'm going to show you how to do it on the calculator real quick. So let me go to the handy dandy calculator as soon as y'all get all that written. The mean, you add up everything and divide by what? Divide by the number. So think of your test grades. You add them all up and divide by how many tests you got. Median. Median is the middle. If n is even, if you've got 12 numbers, you got to take the average of the middle 2 numbers. And we'll go over this. Middle 2 numbers. If n is odd, you just pick the middle number. Mode. MO. MO. What number shows up the what? The most. The range is highest minus what? Highest minus the lowest.
Lowest.
Mid-range is equal to the highest plus the lowest divided by 2. Now, I'm not going to get into the variance and the standard deviation today. I'm just going to show you how to find it on the calculator first. So finish writing that down. And those of you that's finished, I want you to get your calculator out and turn it on. And I'm going to give everybody a few more seconds. I've got like 6 minutes left, so I've got plenty of time to go over this. I'm going to show you how to do all this Wednesday by hand, but I'm going to show you right now how to do it on the calculator. And both are fine. I don't care if you know how to do both. I want you to be able to do both. Okay, so let's pull up the calculator.
I just have.
And I'm going to hit clear and clear. And I'm going to go to stat, hit the stat button, and go and hit edit. And this is your spreadsheet. Okay, now I'm going to clear the second one. I'll show you how to clear it. Go over to L2 if you need to clear it and hit clear. Do not hit delete. If you hit delete, it'll delete the whole column. Hit clear and hit enter.
Oh, I hit delete.
I'm going to go through that again. Stat, edit, and go up to whichever one you want to clear. Go up to L1, L2, hit clear and hit enter. Now, everybody focus on L1 because that's your first column. This is like a spreadsheet. And we're going to put in test grades.
You have a work email.
71, 75, 75, 80, 82, 83, 90. Okay, how many test grades we got? Got 7. 1, 2, 3, 4, 5, 6, 7. Well, since 7 is odd, there's the median right there. You just pick the median. But I'm going to show you how to find all of this just by hitting a few buttons. Hit stat, calculate, first variable stats, and go down and hit calculate. Now, did everybody get to this point? Yes or no?
My stat buttons. I have the TI-30X calculator.
Okay, I don't know if you'll be able to do it on there. You're gonna have to. Okay, what you're gonna have to do, you need to hit Google. You need to go to Google, and you need to say finding stats with TI-8, TI-30, and go on YouTube.
Right.
And it'll show you how to do that.
Okay.
You're gonna have to do that because I'm not familiar.
I have
with
the
TI-30.
30X. If you press the second and then mine's the data key.
Oh, I see it. I see it there. Because I was hitting the one next to it, which is stat variant.
Okay. Whatever y'all say. Thank you, Miss Lacombe. Miss Lacombe, you can talk?
Yeah, I'm sorry. Hold on one second.
Miss Lacombe can talk, y'all. I'm glad you can talk, Miss Lacombe. All right. So here we've got several things. Let me show you what the calculator will give you. Calculator gives you X bar. That is the mean. And in this case, the X bar is equal to 79 point whatever. Okay, now I carry mine to 3 or 4 digits because the test and the homework will usually ask you to round to the nearest tenth of the hundredth. So I usually carry it 4 digits, 4286. 4286. What else do they give you? SX is standard deviation. And that is 6.3471. Now, I can find the variance by taking this number and raising it to the second power. So I'm going to write that down for you. Variance is equal to, parentheses, 6.3471 raised to the second power. So I'm going to take my calculator and go 6.3471 raised to the second power. And that's my variance, 40.2857. And there's one more thing I can get from my calculator, and that's stat, calculate, first variable statistic, sorry, and calculate and go down and get the the second quartile. That's the median. Median is equal to 80. So there are 4 things that you can find right there using your calculator. You can find the mean, you can find the standard deviation, you can find the variance, the median. Let's see, let's go back to the calculator. And I know I'm out of time. Let me go back to the calculator right quick. Where is my calculator? Let me go back to stat, edit. Okay, what is 90 minus 71? 90 minus
19.
71 is what?
19.
19 is your range. And the mid-range, I'm adding these and then I'll shut up. Mid-range, I'll show this to you, is 90 plus 71 divided by 2, which is 161 divided by 2, which is 80.5. I think. Okay, so that's how all of this you found on the calculator. All that you found on the calculator, and then these two. So you should be able, and the reason I say you should be able to do these is because most of you should be able to use a calculator, and then y'all can find these, by subtracting and adding the highest plus the lowest. Subtract, you got the range, add and divide by 2, and you get the mid-range. And we'll talk about more of that Wednesday. Okay, now your homework tonight is to read 2.1 or 12.1 and 12.2 and 12.3. You will start getting into 12.3 with this stuff right here. So I want you to just read tonight. No working problems. I just want you to read 12.1 through 12.3. Any questions on that?
No, sir.
All right, so time is up. If you didn't get counted today, let me check that right quick. Those of you that remember me calling your name out, go ahead and leave. I'm going to look right quick and see who I missed and make sure I didn't miss anybody today. So if you were late, don't leave yet. Let's see. Cassiano, Cowart, Cummins, Elrod. Cassiano, Cowart, Cummins, Elrod. Nope. Mia. Did Mia get in here? I don't see Mia. Who else? Parton and Roberts. Did Parton and Roberts ever come in? And Vanessa? Parton, Roberts, nope. Willis and Wilson, nope. All righty, y'all have a good day. Make sure you leave, and I will stay on here for Mr. Pack. I think he had a question to ask. Let's see, Pack.
Thank you.
Question. Y'all should still be able to see my screen. 155.
Have a good evening, Mr. McClure.
You too, Miss Grindle. Bye-bye.
Bye.
7.1. Milliliters. That's liters right there, milliliters. That's King Henry died drinking chocolate milk.
Okay, because that did not look like an
before?
L. I saw that and I was like, what is that?
King Henry died drinking chocolate milk. King Henry died, meters, liters, grams, drinking chocolate milk. Kilo, hecto, deca, deci, centi, and milli. And these are the basic units. And it says that they want you to go from 1.95 milliliters, which is right here, and go to blank liters. So 1, 2, 3. I just moved 3 places to the left. So you got to move this decimal 1, 2, 3 places to the left. So 1.95 milliliters is equal to 0.00195 liters. That's how you do those. Of course, I'll go over them another time, but hopefully that'll help you out. King Henry died, meters, liters, grams, drinking.
Thank you.
Yes, sir. Have a good one.
You too.